Today's lesson is over section 3.7a. I'm talking about rational functions. A rational function is a function in the form of p of x divided by q of x, where both of those functions are polynomials, like we talked in the last unit. A rational function will have vertical asymptotes, and that is when the function is undefined. This happens when the denominator is set equal to 0 or becomes 0 at any point, and they'll be written in the form of x equals a. They also have horizontal asymptotes, where we'll either say f of x is equal to b or y is equal to b, and that is when your x is approaching positive and negative infinity on the right and left side of your graphs. So how do we find asymptotes? So if I have a function, let's call it r of x for our rational function, vertical asymptote, like I said before, if we set it the denominator equal to 0, we'll be able to find the equation for the vertical asymptote, which will be in the form of x equals a number, a in this case. You may have one or two of these. It's very uncommon that we'll do any that have more than two, but it is possible. Sometimes you could have no vertical asymptote. That's very rare as well, but we're going to kind of stick to one or two. Horizontal asymptotes are found based on the degree of the numerator and the denominator of our polynomials. So we're going to say that the numerator of the is degree of n, and the denominator's degree is m. So the one case that we'll talk about today is when the numerator on the top, n, is less than the numerator on the bottom. And so in those cases, your horizontal asymptote will be in the form of y equals 0. We'll talk about the other two cases in the upcoming videos. So for example 1, I'm going to ignore the directions. I just want you to be able to graph these. So we're going to use our asymptotes and our intercepts to help us graph this. So first I want to figure out what my horizontal asymptote will be. So looking at the n and the m, so the numerator's degree is 0. The denominator's degree is 1. So because the numerator is smaller than the denominator's degree, then that means our horizontal asymptote is y equals 0. For our vertical asymptote, we just look at the denominator and set it equal to 0. So x minus 3 equals 0. Solve. That gives me x equals 3. So that's my vertical asymptote. Okay. Now I want to be able to find my x and y intercepts to help me kind of graph, put them in the right position. So when I figure out my x-intercept, I'm going to actually set f of x equal to 0. So I'm going to replace it, because remember that's y. So trying to solve for the numerator is what I'm kind of trying to do. And so in this case, multiplying both sides by x minus 3, I actually cancel those out, and that leaves me with a 0 equals 2. And that's not equal to each other, so there is no x-intercept, which happens sometimes. For a y-intercept, I'm going to plug in 0 for x and kind of solve for the y value. In this case, I get negative 2/3, so I'm going to have a y-intercept, so I'm going to cross the y-axis. So now, graphing my x and y coordinate plane here, I'm going to use the horizontal and vertical asymptotes to help me do this. So I'll find or graph my x-axis or my vertical asymptote. Now I use a dashed line to indicate that it's not equal to, and it's not really part of your graph. It's like an imaginary line. Horizontal asymptotes on the x-axis because it's y equals 0. So try to make that visible at least a little bit so that I can see it, either darken it or kind of take it off center. Plotting the y-intercept that I have. Now, the reason I can just use one point here is because your graph is always going to be approaching the asymptotes that we've drawn. So they're not really going to usually cross them, especially the vertical asymptotes. They're not going to cross those. And because we already know that there are no x-intercepts, I know I'm not going to cross the x-axis, so that's why I can kind of contain it in that area. On the other side, I have no points. So I actually plugged in the value of 4 for x to figure out what that point would be, and that got me 2. And so then that gave me a little reference point to actually graph on the other side, which keeps it contained as well. So that's kind of what my graph will be. If you want to use more x values to graph, go right ahead. You can do as many as you want, but one and using kind of your understanding of the rational functions is all you really need. So letter B, figuring out my horizontal asymptote. Once again, the degree on the top is 0, degree on the bottom is 1, so it's just y equals 0. Setting the denominator equal to 0 helps me find the vertical asymptote of x equals -2. Okay, and then from there I want to find my x and y intercepts. So plugging in 0 in for f of x and solving for the numerator, that gets me 0 equals 4 divided by x plus 2. And multiply both sides by x plus 2. That leaves me with a statement of 0 equals 4, which is not true. So there is no x-intercept in this problem, just like the last one. If there was an x-intercept, we would have had an x, like it would have been 4x up there, and then I could actually have solved, and that would have made it a little easier. Plugging in 0 for your x to find the y gets me my y-intercept of 0, 2, which is a nice point to graph. So once again, draw my xy coordinate plane. I'll graph x equals -2 for my vertical asymptote, and y equals 0 for my horizontal asymptote. Remember to label your asymptotes as well, so I can kind of see it. And then no x-intercept to graph, so I know I'm not going to cross that. I'll graph the 0, 2. So in that area, in that top right corner that we kind of make, that's good enough for to be able to graph that portion. And then because I have nothing on the left side of the vertical asymptote, I'm going to plug in -3 just to kind of see where I would need to graph or where I can start. So that's going to give me a value of -4. So plotting the value of -3, -4 puts me in the bottom left portion of this graph, and then allows me to kind of complete this rational function. Okay? Okay, good luck.